Hello coders, today we are going to solve another Leetcode daily challenge and the question name is longest square streak in an array. So in this question we have been given an integer array and we have to find a maximum length of a subsequence which should have a length of at least 2, and the second condition is that each element should be the square of its previous number, and if we don't have any subsequence like that we'll return -1. So let's have a quick look on the constraint. So we have a lower bound of length 2 and the maximum length can be 10 to the power 5, and same goes for the element as well. The lower bound is 2 and the upper bound is 10 to the power 5. So let's try to analyze this question. So here I have opened my whiteboard. So I'm going to make one dummy array here and we will try to find the worst case scenario here for the subsequence that we can get. So let us suppose the first element is 2, right? So the another element would be 4 because the square of 2 is 4, right? We are considering the worst case in terms of length if we have a valid answer. So if we have 4, so the next element can be 16, right? Because the square of 4 is 16 and the square of 16 is 256. And we will calculate the square of 256. It will be 6, 5, 5, 3, 6. So if you will try to square this number, it will be greater than 10 to the power 5. So we will never go to this, right? To the next element. So the length here is 5. So we can see if we are even starting from the lower bound, we are getting a maximum length of the subsequence as 5. So that is one of the key points that we can use to make our algorithm here. So let's try to find the brute force of for this. Let us consider if we have the first element as 2. What we will do, we will square this number, right? We will square it and it will become 4. And what we will do, we will find this 4 in our array. We will try to find this, right? And in the worst case scenario, we will find it in O of n time because it can be anywhere in our array. So if we'll find that, what we'll do, we'll again square this number, which will be 16, and we'll try to find it again in our array. So what we are doing a repetitive task of finding a squared up number again and again in our array, which is again increasing our time complexity, right? And it is like for the each element, which is n element, we have n elements, we are trying to again find it in our whole array, which is of length n. So the time complexity is becoming n square, and it's a problem. So we have to solve this problem. What we can do, we can use a hash set, right? Because hash set can find the elements if it is there in our array or not in constant time, which is O of 1. So we'll store this all the elements in our set. What we'll do, for each element we just try to square this number, and we can square up a particular number, n numbers, and we have to square it at maximum 5 times, right? And we can find if it is there in our array or not in a constant time, which is 1, right? With the help of our hash set. So it will be 5n, or we can ignore this 5 because it's a constant. So our time complexity is nearly O of n, and our space complexity, we are just using a hash set of size n at the worst case. So space complexity is also n. So we are doing it in a linear time complexity and a space complexity as well. So let's try to code this. So we have to create a one set of, I'll create a long set because when we'll try to square a number, we might go beyond the limit of integer. New hash set. So we have created a hash set, and we have to store all the numbers which are there in our array in this hash set. So we'll apply a for each loop here, or we can say enhanced for each for loop, and we'll add all the numbers in our set. So we have added all the numbers in our set. So the next step is we will traverse each number in our array, and we will try to square this number, and we'll find if it is there in our hash set or not. So we'll try a while loop here, and in this while loop, what we'll do, if this set contains this number or not, right? And again we'll square this up. So if we have that number, what we'll do, we will increase the count, or we can say the length of our subsequence. Initially it is 0, so I'll mark it as 0. So if it is there, what we will do, we will increase the count. If we are able to find that number in our hash set, so we'll say we'll increase the count and we will square that number, and again we will try to find the, because it is in a while loop, we'll again try to find if it is there in our hash set, and we'll again increase the count. This we are going to do it repetitively until and unless we won't have that number in our hash set. So for like that we can get the length of our subsequence, right? And we have to find the max length. So initially what I'll do, I'll create one variable of length max, and I'll assign it as -1, because initially we have to return -1, and also I'll make it as a long, because as I said, the squared up number can go beyond the integer length. And also here we have to typecast this, because it will also throw an error, runtime error, because it will say the int cannot be converted to long. So now we have got the count for this. Our next step is, we'll see if this count is greater or equals to 2, because we have to find a subsequence of minimum of length 2. Then only we are going to consider it in our answer, right? So then we'll compare it if it's greater than our max answer that we had, and what we will return the max value. Let's try to run it. So it is working fine. I'll show you the code again. We have one hash set, we have added all the number in this hash set. What we have done, we are trying to traverse each number, and from this each number what we are doing, we are squaring it up and checking if it is there in our hash set, and we are just increasing the count, and we are checking if this count is greater than or equals to 2. We are considering it for our max answer, if it is greater than our max or not, and at last we are returning this. Let's give it a submit. So it's done. I hope you guys have understood this solution, and all the best. Thanks for watching.